On this video, I will explain to you how to classify chemical reactions. So there are essentially 5 types of chemical reactions. The first type, a synthesis reaction. Second type, a decomposition reaction. Then single replacement. Double replacement. And finally, a combustion reaction. I will explain each of them by itself. So let's clear everything. So the first type of reaction we have are the synthesis reactions. Synthesis. So a synthesis reaction is also called a combination reaction. It is the same. And you can give it like a kind of formula on how it goes. It's something like this. So A plus B will form AB. So an element will combine with an element 1 will combine with element 2 to form a compound. So an example of it would be when we have sodium and it is reacting with chlorine. We said chlorine is diatomic, so we put the 2 here, and it forms NaCl. Don't worry about the balancing the equation yet. I put the 2 here because of this, but I will be talking about balancing equations in following videos. So all you have to know is that a synthesis reaction is one element combining with another element to form a compound. The second type of reaction that there exists is the decomposition reaction. And you can consider a decomposition reaction as the opposite of a synthesis reaction. So instead of it being A plus B equals AB, it would be AB breaks apart into A plus B. So although it may seem like similar, it is not the same because you have something broken. In a synthesis reaction, you have something formed. So here it is broken. It's like if you had that sodium chloride you had before broken apart again into its elements. It is not the same forming something as breaking something. You have to remember that. Decomposition, the opposite of synthesis, it is breaking a compound into its element. So broken. The third type of chemical reaction that exists are the single replacement reactions. Single replacement. And you can consider this reaction as something like this. So you have an element here, and you have a compound here. And what they react, this element will take this element away. Like if you take a spot from it, so it would form AB plus C. So it is making that element go away it is breaking apart this compound and forming a new compound. So it breaks apart this one to form this one. So an example would be something like this. You have magnesium here plus HCl. So the magnesium would take the hydrogen away, making it MgCl2 plus H2 because hydrogen is diatomic. Then to balance it, we just put a 2 here. But again, don't worry about balancing it. So you can consider this as the A, this as the B, and the C. So hydrogen is the B and chlorine is the C. And it really doesn't matter the order. It could be, this could also be like this. It could be A, C plus B. It doesn't really matter. But in this case, what happened was that the magnesium moved the hydrogen and made a compound with itself. So A, and then the chlorine is C plus the B. So that is what happens in a single replacement reaction. The fourth type of reaction is called a double replacement reaction. Double replacement. And this type of reaction follows the same pattern as the same logic as a single replacement reaction. So you will have something like this: A, B. Instead of one element and one compound, you have two compounds react into. So the A goes with the D and the B goes with the C. So AD plus BC. In this case, it usually follows this pattern. There's no AC or BD, because the A is usually the metal, and the metal will react only with the D, which would be the non-metal of the second compound, and the B would be the non-metal of the first compound, and the C the metal of the second compound. So you just say metal, non-metal, metal, non-metal. And an example makes it easier to visualize. So let's say we have HCl plus NaOH. So the hydrogen would be the cation of this reaction, so it will go with the anion of this reaction. The anion of this reaction, to visualize better, this is plus, minus, plus, minus. Plus will go with minus, and minus will go with plus. So hydrogen will form H2O because it will have H and OH, H2O, water. The sodium will go with the chlorine, so NaCl. And it follows the same way. This is A, this is B, C, D, and what was formed was AD, BC. So double replacement reactions, you can't get it wrong. It always follows this same pattern. Now the last type of reaction are called the combustion reactions. Combustion reactions are a little complicated because they have a lot of calculations on them. So I'll get more into them, more specifically into them in a video in the future. So here I'm just going to explain how the model works. So you'll have like a fuel, which is an organic compound usually, and an oxidant, which will most likely be oxygen. So you have something organic, like let's say C3H8, and your oxidant will be the oxygen. As it says, oxygen, oxidant. And you will always form CO2 and water. However, the only thing that will change is the number. So this may be at 2, it may be at 3, this may be at 5. That is, it needs a combustion analysis, and that is what I'll get in a following video. So all you have to know for now is that it will have an organic, let's call it better a fuel, because they're not organic all the time. Fuel, plus oxidant, usually oxygen most of the time. Then you will always have a given amount of CO2 plus a given amount of water. So fuel and oxygen will form CO2 and water. That is what you have to know about combustion for now. And well, those are the 5 types of chemical reactions.